most likely time. TP, TM, TO. So in this method, these are the important formulas. First one, TE. So TE is nothing but so distance between any two nodes. Distance between any two nodes. So formula TO plus TP plus OTM divided by 6. So next. So this is variance. So variance sigma square is equals to TT minus T naught divided by 6 whole square. So this is variance. So variance sigma square is equals to TP minus T naught divided by 6 whole square. So these are the two important formulas in PERT. Example 5 is when activity and TO, TM, TP. So optimistic time, most likely time, and pessimistic time. So these are denoted by A, B, C, D up to H. Example 5 up to H. And to draw a, we have to draw project network diagram, identify critical path. And so what is the expected time to complete the project? Second one. Third one, what is the probability of completing the project in 20 weeks or less? So these are the 3 points. First, we have to draw the network diagram and identify critical path. So next, what is the expected time to complete the project? Is given activity and TO, TM, TP. So up to here question solution. So first we have to draw the network diagram for the given data. So these are the activity. So A is nothing but 1 to 2, B 1 to 3, 1 to 4. So next 2 to 4, 3 to 4. Next 4 to 5, 2 to 5, 3 to 5. So processor activity A, C, A, B, C, D. This is given question. So next P, O, optimistic time. So TM, TP. So next we have to find out the distance between two nodes, 1 to 2. So the nodes distance between two nodes is TE. So TE formula TP plus T naught plus 4TM by 6. So calculate this one. So we are getting 3. The distance between 1 to 2 node A, that is 3. So similarly 1 to 3, same formula TO plus TP plus 4TM divided by 6. So this one. So we are getting here also 3. So next 1 to 4 distance. So 1 to 4 distance 4. Same formula. So next 2 to 4. 2 to 4 8. 3 to 4 5. 4 to 5 7. 2 to 5 4. Next 3 to 5 H. So that is 19 by 6. So this is the activity and each and every activity distance. Activity, this is the distance. Activity, distance. So we can draw the network diagram using the activity, activity and distance. Activity and distance. So first 1 to 2. So 1 to 2 distance is 3 units. So we can draw node 1 to node 2. Two nodes. The distance between these two nodes is 3 units. Next 1 to 3. Second one 1 to 3 distance is 3. So 1 to 3, 1 to 3. Two nodes. We can draw another node 3. The distance between 1 to 3 is 3 units. Here 3 only. So next 1 to 4. 1 to 4. 1 to 4. So this is 1 to 4. The distance between these two nodes is 4 units. So next, 2 to 4. So 2 to 4. So this is 2 to 4. The distance is 8. So 2 to 4, distance is 8. So next, 3 to 4. 3 to 4, distance is 5 units. Here 5. So next, 4 to 5. So 4 to 5, distance is 7 units. So distance 7 units. So next, 2 to 5, distance is 4 units. So this is 2 to 5. 2 to 5, distance is 4 units. So similarly, 3 to 5, distance 9 by 19 by 16. Same previous class method. How to draw a network diagram. Previous two classes. So using activity and distance. T is nothing but distance between nodes. So this is the network diagram. So next, we have to identify critical path. So previous method, we have to identify critical path is nothing but we have to find out latest finishing time, earliest starting time. So latest finishing time of all nodes 1, 2, 3 up to 5 nodes. So next 1, 2, 3 to 5 nodes. Each and every node latest finishing time and earliest starting time. We have to find out earliest starting time and latest finishing time of 1, 2, 3 up to 5 nodes. So earliest starting time. Earliest starting time, starting node is always 0. Starting node always 0. So ES1 is equals to 0. Next, second node. Second node is connected to only single node. So that is first node. So formula ES1 plus T1 comma 2. Distance between two nodes. So 1 comma 2. So that is 0 plus 3. So that is 3 arms. Next, ES3, ES4, ES5 up to 5 nodes. So previous method we can calculate. So third node is connected to only single node. So previously. So that is ES3 is equals to 4. Here 0 plus 4. That is 4. Next, fourth node is connected to two nodes, 3 and 2. So in these two nodes, we can take maximum. So maximum of 2 or 3. So next, fifth node is connected to three different nodes. So fifth node is connected to second node and fourth node and third node. In these three nodes, so we can take maximum. So like this. ES3 is equals to ES1, T1 comma 3 is equals to 4. So next, ES4 is equals to maximum of fourth node is connected to three different nodes. First node, second node, third node. ES1, T 1 comma 4, ES2 plus 2 comma 4, ES3 plus T comma 3 comma 4. So in this maximum value is 11. So this is the maximum value. So next, fifth node. So fifth node also connected to three different nodes. So these are three different nodes. Here also we can take maximum. 18 is maximum. 11 plus 7. So this is previous class. How to calculate earliest starting time and latest finishing time. So this is 18. So next, backward pass computations. That is latest finishing time. Here also 3. So but in backward pass computations, latest finishing time. So latest finishing time is equals to earliest starting time. So these two are equal. So that's why LFI is equals to, we are taking directly 18. Here 18. So next we can calculate fourth one. So fourth node is connected to single node, that is fifth. So 18 minus 7. 18 minus 7 is equals to 11. So that is latest finishing time of node 4 is equals to 11. So next. So third node is connected to only single node. Third node previously connected to node 5. So that is 18 minus 18 minus 19 by 6. So this is the ES3, LS3. So LS3 is equals to 6. So this is the 6. So next, third node. Third node previously connected to node 5. So that is 18. 18 minus 18 minus 4, second node. So that is ES3, LS3. Second node is connected to second node is connected to two different nodes. So previously, so connected to node 5 and also connected to node 2 or node 4 also. So here 18 minus 4, first first one. This is 18 minus 4. So next here 11 minus 8. So that is 3. 11 minus 8 is equals to 3. So this is LF2 is equals to answer 3. So next, this is 0 always. L1 is equals to 0. So these are the forward pass computations and backward pass computations, same as previous class. So next we can identify critical path. So in this method, how to identify critical path? So we can write all latest starting time and earliest finishing time. Earliest starting time and latest finishing time of each and every node. At which node, at which node ES is equals to LF. Latest starting time is equals to earliest starting time is equals to latest finishing time. At which node we can these two are equal, we can identify the nodes. So first one, node one, LS1 is equals to ES1 is equals to LF1. So first node. So this is first node. So next, first node, third node. So third node is different. 4 comma 6. So third node is different. So we cannot consider third node. So next here, second node. Second node, 3 comma 3. So 1 2 3. 1 2 3. Path. So next. So second is connected to 4. So here we can identify ES4 and LF4. So these two are equal. So draw the path here. So next, last. Last 18 is equals to 18. So therefore path 1 to 2, 2 to 4, 4 to 5. So that is A plus D plus F. So this is the critical path. That is so plus A to D, D to F. The critical path 3 plus 8 plus 7 is equals to 18. So 18 weeks to complete the total project. So this is the third one. The next variance. We can calculate variance formula sigma square is equals to sigma square is equals to TP minus T naught by 6 whole square. So this is the variance. So directly we can calculate in calci, scientific calci. So TP minus T naught by 6 whole square. So these are the variances. So TP here. So these are the TP values. So next T naught values 1, 2, 3, 2, 4, 5, 2, 1. So divided by 6 minus whole square. So this is the variance. So this is the critical path. The total duration of project completed 3 plus 8, 11 plus 7, 18. 18 weeks to complete the total project. And also variance. Variance formula TP minus T naught by 6 whole. So this is CPM. Next example 6 is also there. Examples also. So this is the CPM and PERT. So these topics are very important for your examination point of view. 100% long question in these topics. CPM or PERT. So next topic. So next one, Unit 2, LPP, Linear Programming Models and Solutions, Graphical and Simplex Methods. So graphical methods. So this is important for SEAQ, short answer question. Graphical methods. Working procedure to solve the LPP graphically. Formulate the given program problem as a LPP mathematically. So first step is nothing but so given LPP in mathematically express the given linear programming problem in mathematically. So next denote the coordinates I, xi, x1 I, x2 as axis. So like this x1 axis and x2 axis. So 1, 2, 3 numbering. So these are the origin. So below origin -1, -2. So this is x1 axis. So this is x2 axis. Same as here also numbering units 1, 2, 3, 4. So these are negative -1, -2. So second step is nothing but represent two axes. So first one x1 axis and x2 axis. So these are the construction of x1 and x2 axis. Take the constants inequalities to. So this is the process. So it's very simple. So directly we can go to example one. Example. So minimum of z is equals to 1000 x1 plus 800 x2. So subject to constants 6x1 plus 2x2 greater than or is equal to 12. 2x1 plus 2x2 greater than or equals to 8. Third constants 4x1 plus 12x2 greater than or is equals to 24. And x1 comma x2 is greater than or is equals to 0. Solve the following LPP by graphical method. So example 2.1. First we have to construct the graph here. So these are the constants. Three equations. 6x1 plus 2x2 greater than or is equals to 12. First equation. So next, second equation, 2x1 plus 2x2 is greater than or is equals to 4. So next, 4x1 plus 12x2 greater than or is equals to 24. So we can construct graph. So this is x1 axis. So this is x1 axis. In x1 axis 0, 1, 2, 3, 4, 5, 6 units. Here also this is x2 axis. So in x2 axis 0, 1, 2, 3, 4, 5, 6. So like this. So next. So draw a lines. So first equation. First equation 6x1 plus 2x2 is equals to 12. So this is the first equation. So we can take x1 is equals to 0. X1 is equals to 0. So to substitute on in this equation, x1 is equal to 0, x2 value is 6. So this is the first point. So next, x2 is equals to 0. X2 is equals to 0. X1 is equals to 2. So these are the 2 points are denoted by 6x1 plus 2x2 is equals to 2. Is clear? So points are first point 2 comma 0. Second point 0 comma 6. Is clear? So taking x1 is equal to 0, we are getting x2 value 6. This is the first point. So next, so taking x2 is equal to 0, so we are getting x1 is 2. So this is the second point. So these 2 points are representing the line 6x1 plus 2x2 is equals to 12 in a graph. That is. So first point 0, comma 2, 0, comma 2, x1 is equal to 0, 0, comma 6, 2, comma 0. So these are the 2 points. So here 2 on x1 axis. So here 2 point 2, comma 0. So x1 axis 2 and x2 0. That is here. Point on here. So next 0, comma 6. So 0, comma 6 is nothing but 0 on x1 axis, 6 is x2 axis. So these are the 2 points. So here. So this line is representing 6x1 plus 2x2 is equals to 12. Is clear? So taking x2 is equal to 0, we are getting x1 2. Taking x1 is equal to 0, we are getting x2 is equal to 6. So draw a line joining these 2 points on x1 and x2 axis. Draw a line joining these 2 points on x1 and x2 axis. That is 6x1 plus 2x2 is equal to 12 line. So this is the line. So next, similarly, here second line. Second line 2x1 plus 2x2 is equals to 8. So here also same. X1 is equal to 0, x1 0, x2 value 4, x2 0, x1, x2 0, x1 value 4. So this is the 2 points representing the line 2x1 plus 2x2 is greater than or is equals to 8. Is clear? So these are the 2 points representing the line 2x1 plus 2x2 is equals to 8. So now identify that these 2 points in a x1 and x2 axis. So this is the x1 4, comma 0 on x1. So next, so this is the 0, comma 4, 0, comma 4. So this line is 2x1, 2x1 plus 2x2 is equals to 8. So draw a line joining these 2 points. So this is 2x1 plus 2x2 is equals to 8 line. So next, so similarly, last one. Here x1 is equals to 0, x2 is equals to 2, and x2 is equals to 0, x1 is equals to x2 0, x1 6. So these are the 2 points representing the line 4x1 plus 12x2 is greater than or is equals to 24. The first point 6, comma 0. So this is 6, comma 0, 6, comma 0 point. So next 0, comma 2. So 0, comma 2. So this is 0, comma 2. So these are the 2 points. So now we can draw a line connecting these 2 points. So that is 4x1 plus 12x2 is equals to 24. So these are the 3 lines. So now the 3 lines are touching at a point. So first one C. So next A. So next B. Next D. So 3 lines are touching at a point, A point, B point, C point, D point. So now all the constants are greater than or is equals to first line, second line, third line. All the constants are greater than or is equals to 0. So that's why we are taking boundary here, upper side. So we can take the boundary upper side. So that is, so these are the boundary area. So this total. So this total is boundary area because all constants are greater than or is equals to. In case if the all constants are less than or is equals to, so lower side, lower boundary, we can take lower boundary. So here all constants are greater than or is equal to 0. So we can take upper side of the boundary. So the boundary area. So this is the boundary area. So the boundary area touches to x1 axis at a point A, next B, next C, D. We can identify these 4 points. So first A point 6, comma 0, 6, comma 0. So B point. So B point is 3, comma 1. So this is 2. This is 2. Next point 3. So here 0, middle of the 0, comma 2 is 1. So that is, so this one. So this is 3 comma 1, B point. So next we can identify C point. C point. So this is P, 3 comma 1. So next B point. Uh, C point. C point. So here 1. So this is 1. Next here 3. So that is 1 comma 3. C point is 1 comma 3. So next D point. D point is 0 comma 6. 0 comma 6. So therefore the boundary points are 6 comma 0, 3 comma 1, 1 comma 3 and 0 comma 6. So these are the 4 points on a boundary line. Is clear? So this is the total matter. So we can take x is equal 0, x1 is equal 0. We are getting 2 points, 2 comma 0, 0 comma 6, 4 comma 0, 0 comma 4. And also third line, we are taking intersecting point, x1 is equal 0, x2 is equal 0. So this is the total matter, total theoretical matter.
సార్ సార్ ఈ థియరీ
చెప్పండి.
మొత్తం రాయాలా సార్ ఎగ్జామ్ లో?
అవసరం లేదు నాన్న,
అంటే
అవసరం లేదు. థియరీ
నార్మల్ గా ఇదే
థియరీ
ప్రాబ్లం
లేదు లేదు,
చేసినట్టు చేస్తే చాలు కదా సార్?
ప్రాబ్లం చేస్తే సరిపోతుంది. ఎలా అంటే టేకింగ్ x1 is equal 0, x2 is equal 0, ద పాయింట్స్ ఫస్ట్ లైన్ రాయాలి ఇక్కడ. 6x1 plus 2x2 is equals 12. ఫస్ట్ ఈక్వేషన్ రాసిన తర్వాత టేకింగ్ x1 is equal 0, ద పాయింట్, x2 is equal 0, పాయింట్. సిమిలర్లీ 3 లైన్స్ అలా రాస్తే సరిపోతుంది. ఇదంతా థియరీ అవసరం లేదు. ఇప్పటిదాకా చెప్పిన థియరీ మొత్తం ఇక్కడే ఉంది. 4,0 పాయింట్, 0,6, 6,0 ఆ పాయింట్స్. And if the all constants are greater than or equal 0, we are taking upper side of the boundary. సో ఈ మ్యాటర్ మొత్తం ఇక్కడ ఉంటుంది మీకు. ఇదంతా రాయాల్సిన అవసరం లేదు, జస్ట్ ప్రాబ్లం లెక్క రాస్తే సరిపోతుంది. మీకు కావాలంటే నోట్స్ చేంజ్ చేస్తాను నేను. నాకు థియరిటికల్ గా రాసిన నోట్స్ ఉంది, క్లాస్ అయిపోయిన తర్వాత పంపించేస్తాను.
అంటే థియరీ రాయడం రాదు సార్, అంటే లెక్క అర్థం చేసుకొని
థియరీ
చేయడం.
అవసరం లేదు
లెక్కలు
నానా,
వస్తాయి కానీ
థియరీ అవసరం లేదు. డైరెక్ట్ మీరు ఇందాక చెప్పినట్టు x1 is equal 0 పాయింట్, x2 is equal 0 పాయింట్ అలా రాయండి అంతే. ఇదంతా థియరీ రాయాల్సిన అవసరం లేదు. ఇంత థియరీ రాస్తే సరిపోదు, నీకు టైం సరిపోదు, పేపర్స్ కూడా సరిపోవు. అవసరం లేదు థియరీ అంతా. డైరెక్ట్ ఎలా చెప్పాను అలా రాసేయండి. నేను చెప్తున్నాను, నోట్స్ పంపించేస్తాను, అందులో థియరీ క్లియర్ గా ఉంటుంది. అవసరం లేదు థియరీ అంతా.
ఓకే సార్.
నెక్స్ట్ 4 పాయింట్స్, ఏ పాయింట్, బి పాయింట్, సి పాయింట్, డి పాయింట్. At A, B, C, D values, at A, B, C, D values, we can find out minimum of Z. So this one. So minimum of Z is equals to 1000 x1 plus 800 x2. At a point A, 6 comma 0, x1 is equal 0, x2 is equals to, x1 is equal 6, x2 is equal 0. That is 6 days on A and no work on B. So that is maximum of Z, minimum of Z is equals to 6000. Starting equation, 1000 into x1 plus 800 into x2. That is minimum of Z in question. So this is minimum of Z. Substitute x1, A point, B point, C point, D point on here. Minimum of Z. So each and every point we are getting values. First point, A point, minimum of Z is equals to 6000. So next B point, 3 comma 1. x1 is equals to 3, x1 is equals to 3, x2 is equals to 1. So that is minimum of Z is equals to 3800. So next at C point, 1 comma 3, x1 is equals to 1, x2 is equals to 3. So that is minimum of Z is equals to 1000 plus 2400. So that is total 3400. So next point, D point, 4800. In this all values, so minimum of Z is nothing but 3400. So that is point 1 comma 3. At a point 1 comma 3, the problem is minimum. So therefore, the minimum value is 3400. So this is the answer. Since our problem is a minimization one, the minimum cost is 3400 per a week at a point 1 comma 3. So therefore, x is equals to 1 and x2 is equals to 3. So minimum of Z is equals to 3400. So this is last step. So this is the answer. It is enough. Next, example 2. Example 2. Example 2.2. So previous example is greater than or is equals to all constants. Here less than or is equals to case. So less than or is equals to case. So let x1, x2 represent. So this is the given question. A pineapple farm produce two products, namely. So here data is given. So labor, equipments, material. So this is juice, pineapple, available resources. So this is x1, x2, x1, x2, x1, x2. So data 3x1 plus 2x2 is less than 12. So x1 plus 2.3 x2 less than 6.9, 1 plus 1.4 x2 less than 5.6. So is given. So data, based on this data we are taking less than. So these all are constants. So now we can consider objective function. Objective function is 2x1 plus x2. So that is, so profit. Profit of margin of 2 rupees. So that is 2x1 and cost 1 rupee. So this is the objective function. So that is maximum of z is equals to 2x1 plus x2. So this is objective function. So these are subjected to constants. 3x1 plus 2x2 less than or is equals to 12. So next x1 plus 2.3 x2 less than or is equals to 6.9, x1 plus 1.4 x2 less than or is equals to 5.6. Material, labor, equipment constraints. So these are three cases. And so these are objective function is based on cost. Maximum of z is equals to, so 2 rupees and 1 rupee is there respectively. Demand. So that is 2x1 plus x2. Same here also we can construct. We can draw graphical diagram. So first we can take two axes, x1 axis. So this is x1 axis. So now, so this is x2 axis, x1 axis and x2 axis. So 0, 2, 4, 6, 8. Here also. In x2 also 0, 2, 3, 4, 5, 6. We can take order, orderly 1, 2, 3, 4. Here also 1, 2, 3, 4. So this is x1 axis, this is x2 axis. So next, first line, 3x1 plus 2x2 less than or is equals to 12. So taking x1 is equal 0, x1 0. So we are getting x2 is equals to 6. First line. So next, x2 0, we are getting x1 is equals to 4. So that is 0 comma 6 and 4 comma 0. These two lines are, these 2 points are representing the labor constraints. Is nothing but 3x1 plus 2x2 less than or is equals to 12. So directly we can write in examination point of view, first line, we can write first line at x1 is equal 0. At x1 is equal 0, the point 0 comma 6. Next, at x2 is equals to 0, the point x2 0, 4 comma 0. So these are the 2 points representing the labor equation. So we can draw the equation on a graph. So 0 comma 6, 6 comma 0. So first 6 on x1 axis, 0 on x2 axis. That is 0 comma 6. So next, second one. So 0 comma 4. So 0 comma 4 is here. 0 comma 4. This line is, we can draw a line connecting these 2 points. So that is x1 plus 4 comma 0, 0 comma 4. Yeah, different lines. Uh, so points are 4 comma 0 and 0 comma 6. These are 2 points. So these are 2 points. So first one 4 comma 0. 4 comma 0. So the here 4 comma 0. So next 0 comma 6. So 0 comma 6. So these are the 2 points. So we can draw a line connecting these 2 points. That is 3x1 plus 2x2 is equals to 12. So this is the first line. So next, second line. The second line x1 plus 3.2x2 less than or is equals to 6.9. So here x1 is equals to 0, x2 3. x1 is equals 0, x2 3. So next, x2 is equals to 0, x2 0, x1 6.90. So that is 6.990. So these are the 2 points. So this is 0 comma 6, 0 comma 3. So here 0 comma 3 and 6.9. So here 6.9. So two lines are 0 comma 3 and 6.9 comma 0. So these are 2 points representing the second line, second constant. So here 0.0 comma 3 and 6.9 comma 0. So draw a line connecting these 2 points, that is x1 plus 2x2 is equals to 6.9. So next, last one x1 plus 1.2 x2 less than or is equals to 6. So here x1 is equal to 0, x1 0, x2 value 4, x2 0, x1 value 6. So these are the 2 points. So representing the last line. So that is, so 6 comma 0 here and 0 comma 4 here. So draw a line connecting these 2 points. So that is x1 plus 1.4 x2 is equals to 5.6. So these three lines. So these three lines. So next, all the constants are less than. In this case, so we can take lower region. So that is, so this is the lower side of the boundary. So lower region. So the boundary lines are A point 4 comma 0, B point 3 comma 1.5, and third one C 0 comma 3. So these 3 points are boundary lines of or boundaries of the lower region. So that is less than or is equals to case. At these 3 points, the given objective function maximum of z is equals to 2x1 plus x2.
సార్
So first point. చెప్పండి.
సార్ థర్డ్ ఈక్వేషన్ లో x2 0 అయితే x1 5.6 వస్తుంది కదా సార్.
లేదు x2 0 అయితే 5.6
X
వస్తుంది.
సార్
అవును 5.6 వస్తుందమ్మా.
సార్
ఇప్పుడు
6
ఏమొస్తుందండి?
6 తీసుకోవాలా సార్ అక్కడ?
5.6 లేదు 5.5. ఈక్వేషన్ అది లాస్ట్ ఈక్వేషన్ కదా. 5.6 5.6 నియర్లీ ఇక్కడ వస్తుందమ్మా మనకి, కానీ ఇక్కడ ఇచ్చారు ఇక్కడ వస్తుంది. కొంచెం డైరెక్ట్ అంటే నార్మల్ డ్రా చేస్తే సరిపోతుందమ్మా, అక్యురేట్ వాల్యూస్ అయితే రాదు ఇక్కడ మనకి, గ్రాఫ్ కాదు కదా. 5.6 అంటే ఇక్కడ తీసుకోండి. x1 0 అయితే x2 0 అయితే x1 వాల్యూ 5.6 వస్తుంది. ఎస్ ఇక్కడ వస్తుంది 5.6
అది
ఇక్కడ
దాన్ని
వస్తుంది.
అయితే ఇక్కడ దీన్ని డిస్టర్బ్ చేయట్లేదు కదా సార్, లోపల అది ఏం ప్రాబ్లం లేదు కదా సార్ దాంతో.
దీంతో ప్రాబ్లం ఏం లేదు, కానీ
లోపల
మీరు
దీన్ని
డ్రా చేస్తే
డిస్టర్బ్ చేస్తే దాంతో ఏమైనా ప్రాబ్లం అవుతుంది, అంతే కదా సార్?
ఏం కాదు, ఈ లైన్ అసలు టచ్ చేయట్లేదు ఇక్కడ కూడా, ప్రాబ్లం ఏం కాదు. కానీ ఇక్కడ డ్రా చేయాలి కొంచెం, ఇక్కడ వస్తుంది 5.6 అంటే ఆ రెడ్ మార్క్ దగ్గర. ప్రాబ్లం ఏం లేదు, ఈ ఓన్లీ కనెక్టింగ్ ఈ బౌండరీ మనకి ఏబిసి వాల్యూస్ కావాలంటే
సార్
ప్రాబ్లం
బి
లేదు. ఇక్కడ
వాల్యూ
వస్తుంది బి వాల్యూ చెప్పండి అమ్మ.
బి వాల్యూ ఇక్కడ 2 వస్తుంది
ఇక్కడ
కదా
త్రీ
సార్?
త్రీ వస్తుంది. ఇది యాక్చువల్ గా 3 కాదు, 2 కదమ్మా, ఇది ఇక్కడ కొంచెం కిందికి వస్తుంది మనకి. నార్మల్ గా స్కేల్ పెట్టి డ్రా చేస్తే మనకి కిందికి వస్తుందమ్మా, 1.5 దగ్గర వస్తుంది ఎగ్జాక్ట్లీ.
అవునా సార్?
మీరు ఒకసారి డ్రా చేయండి, వస్తుంది కరెక్ట్ ఎగ్జాక్ట్లీ వస్తుంది. నేను నోట్స్ కూడా పంపించేస్తానమ్మా, మీకు కావాలంటే నాకు మెసేజ్ చేయండి, పంపించేస్తాను మీకు.
సరే సార్.
సో 3 పాయింట్స్, ఫస్ట్ పాయింట్ 4 comma 0, సెకండ్ పాయింట్ 3 comma 1.5, 0 comma 3. సో ఫస్ట్ పాయింట్ 4 comma 0, ఆబ్జెక్టివ్ ఫంక్షన్ is 8. ఆబ్జెక్టివ్ ఫంక్షన్ 2x1 plus x2. So this is the objective function. So 2 into x1 4, 8. So next 6 plus 1.5, 7.5. Next third point C 0 comma 3. So that is 3. So but here is given objective function is maximum. So maximum is nothing but we can take maximum value. So maximum value is 8. So here we are taking 8. So therefore the maximum value of Z is attains at a point 4 comma 0. So therefore the maximum profit of rupees 8 rupees. So this is the second example. So these are the graphical methods. Graphical method examples. So next, general linear programming problem. So that is standard form or matrix form. చెప్పండి.
సార్ ఎగ్జామ్స్ డేట్స్ వచ్చాయి కదా సార్.
అవునండి.
సార్ మోడల్ పేపర్లో క్వశ్చన్స్ ఏమైనా కొంచెం ఎక్స్ప్లెయిన్ చేస్తారా సార్?
మోడల్ పేపర్ లో క్వశ్చన్స్ సరే అమ్మా నెక్స్ట్
అవును
క్లాస్
సార్.
నుంచి మోడల్ పేపర్ క్వశ్చన్ చెప్తాను నేను.
సార్ థ్యాంక్ యూ సార్.
ఓకే. సో జనరల్ ఎల్పిపి స్టాండర్డ్ ఫార్మ్ అండ్ మ్యాట్రిక్స్ ఫార్మ్. సో స్టాండర్డ్ ఫార్మ్ ఆఫ్ ఎల్పిపి. సో స్టాండర్డ్ ఫార్మ్ ఆఫ్ ఎల్పిపి. సో దిస్ ఇస్
సార్
ఇంపార్టెంట్ వన్.
ఇంతకీ
స్టాండర్డ్
ఎల్పిపి అంటే ఏంటి సార్?
లీనియర్ ప్రోగ్రామింగ్ ప్రాబ్లం. స్టార్టింగ్ లో ఫస్ట్ యూనిట్ లో డెఫినేషన్స్ ఉంటాయి.
ఓకే సార్.
ఫస్ట్ యూనిట్ లో మేము ఆల్రెడీ ఆఫ్లైన్ క్లాసెస్ లో డీల్ చేస్తాం మేము అన్ని ఇంపార్టెంట్ టాపిక్స్ మళ్ళీ చెప్తున్నాం. అక్కడ చెప్పిన టాపిక్స్ ని ప్లస్ ఇంపార్టెంట్ ఏవైతే ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ లో ఇంపార్టెంట్ ఉంటుందో ఆ క్వశ్చన్స్ మాత్రం మళ్ళీ మళ్ళీ రిపీట్ చేస్తాం.
ఓకే సార్.
సో హియర్ స్టాండర్డ్ ఫార్మ్ ఆఫ్ ఎల్పిపి. సో ఫస్ట్ స్టెప్ ఇస్ నథింగ్ బట్ ఆబ్జెక్టివ్ ఫంక్షన్ is maximum. Objective function is maximum. In case given function is given objective function is minimum, we can convert the minimization to maximization of objective function. So that is multiply both sides by negative minus. So like this. So in previous example here, first example here standard form of LPP is nothing but, so in first example here minimization is there, minimum of Z. So we can convert maximum. So maximum is nothing but, so we can multiply maximum of Z is equals to negative minus 1000 x1 minus 800 x2. So this is the maximization of objective function in standard form. First step is nothing but to convert minimization of objective function to maximization. In case is given maximization, there is no need to change. In case given objective function is minimum, we can convert minimization to maximization, multiplying minus on both sides. So this is the first step, standard form. So next, second step. In second step, so here the subject constants are less than or is equals to. So subject constants are less than or is equals to case. So this one, 2x1 plus 3x2 less than or is equals to 5 is there. So we can convert inequalities to equality. So that is less than or is equals to or greater than or is equals to equality is nothing but equations, equality. So we can convert inequalities to equality. That is less than or is equals to greater than or is equals to equality. So for example, 2x1 plus 3x2 less than or is equals to. So here changes to 2x1 plus 3x2 plus x3 is equals to 5. So here less than is nothing but so this is smaller compared to 5. 2x1 plus 3x2 is less than or is equals to 5 is nothing but, so this is smaller compared to 5. So that's why we are adding some variable. So that is plus x3. So this is called slack variable. So this is x3. So we can add something to LHS. This is converted to equality. In inequality converted to equality, that is 2x1 plus 3x2 plus x3. Why we are adding x3 is nothing but, so this is small compared to 5. So to make it equality, so we can add something, that is one variable x3. So x3 is equals to 5. In case, so here less than or is equals to 3. In case greater than or is equals to, in greater than or is equals to case, so minus x3. In greater than or is equals to case, minus x3. So here is given, so 3x1 minus x2 greater than or is equals to 6. So this is higher than compared to 6. So that's why we have subtraction of x3 minus x3 to make inequality to equality. So 3x1 minus x2 minus x3. So we are taking minus x3 because this is a higher value compared to 6. Minus x3 is equals to 6. So these are the inequalities to converting equalities. So this is the second case. So these are the how to convert minimization to maximization. So next, so express the following. So listen. Example, express the following LPP linear programming problem in standard form. So minimization of objective function and all are inequalities. All are inequalities. So another case is there, unrestricted sign. Any variable unrestricted. Okay, can see first here after this. Yes. Express the following LPP into standard form. So here minimization is there. So we can convert minimization to maximization. So multiply both sides by negative. So minus 5x1 plus 2x2 minus 3 into x3. So maximum of z dash is equals to minus 5x1 plus 2x2 minus 3 into, so this is x3. X3 is unrestricted sign. In this case, so this is rare case, x3's unrestricted sign is nothing but, so we can replace x3 is equals to x3 dash minus x3 double dash. If the variable is unrestricted sign, because x1 is greater than or is equal to 0, x2 also greater than or is equal to 0. But here there is no sign, or negative, x3 is negative or positive or 0. We don't know. In this case, we can take or replace x3 value in total equation. In the total equation, x3 dash minus x3 double dash. And x3 dash is greater than or is equal to 0. And x3 double dash is greater than or is equal to 0. So that's why we are taking x3 dash and x3 double dash on here. So first we can convert minimization to maximization, multiply both sides by minus. So that is maximum of z dash. So maximum of z dash is equals to minus 5x1 plus 2x2 minus 3. So unrestricted sign is nothing but replace x3 dash minus x3 double dash. So this is the unrestricted sign case. So next, subjected to constants. So subjected to constants. So here less than or is equals to case of first one. So less than or is equals to case is nothing but here already x3 up to x3 variable is completed. So next we are taking x4. So this is less compared to 6. In this case, we can add a variable x4, x1 plus 2x2 plus 4 in place of x3 dash minus x3 double dash. This is unrestricted sign. Plus x4 is equals to 6. We can make less than or is equals to equality. So next, second one, greater than or is equals to 0. Greater than or is equals to 7. In this case, subtraction of x5. So 3x1 minus 5x2 plus 2 into x3 dash minus x3 double dash because x3 is unrestricted sign. So each and every case replace x3 is equals to x3 dash minus x3 double dash. So here x3 dash minus x3 double dash minus x5 because to convert greater than or is equals to equality. So we can subtraction of x5. So this is equals to 7. So next, third one. Third one also minus minus x6 because here greater than or is equals to there. So and also here negative is there. First here negative is there. In RHS minus 2 is there. So total equation multiplied by minus on both sides. Minus 2x1 minus x2 minus 3x3 is less than or is equals to 12. So we can multiply minus on both sides. Less than or is equals to greater than or is equals to converted into less than or is equals to. So here minus 2x1 as it is minus 2x1 minus x2 minus 3 into x3 is nothing but x3 dash minus x3 double dash. Here less than or is equals to there is nothing but we can add something that is plus x6 is equals to 2. So these are the inequalities to converting equalities. So next here variables. So declaration of variables x3 x1 greater than or is equal to 0 and also x2 greater than or is equals to 0 here. Next, x3 is unrestricted sign. In place of x3, we can replace x3 dash, x3 double dash, x3 double dash, and x3 dash greater than or is equals to 0. These are. So next, adding variables x4, x5, x6. So these all are also greater than or is equals to 0. x4 greater than or is equal to 0, x5 greater than or is equal to 0, x6 also greater than or is equal to 0. So these are the declaration of variables. So this is the standard form of LPP. So next another example is there. So this is reduce the following LPP into standard form. Maximization. Given problem is already is maximization, there is no need to the next standard form of LPP. So given objective function is already is maximization, there is no need to change objective function. So next, subject to constants. So first constant. So we can add here plus the first constant minus 2x1 plus 4x2 minus plus x3 is equals to 4. So we can add some variable, so that is x3. So less than or is
X4
equals to z.
X4 యాడ్ చేయాలి సార్. ఆల్రెడీ X3 ఉంది ఆడ.
3 is there. So x4. So this is x4. x3 is there. So we can add some x4. So next here, so minus x5. So here minus x5. So this is greater than or is equals to sign. So that's why we are taking minus x5. So here less than or is equals to sign is there, plus x6 for third one. So this one plus x6. First, we can multiply minus on both sides because there is a negative term is there. Negative term is there. So minus 2x1 minus 3x2 greater than or is equals to 2. After multiplication of minus, so we can convert inequality to equality. So that is minus x6. So this is the last one. Minus 2x1 minus 3x2 minus x3 minus x6 greater than or equals to 2. So this is the standard form of LPP. So next, matrix form of LPP. After converting standard form, so we can write matrix form of LPP. So, so this is the standard form of LPP. So we can write matrix form of LPP. So here, objective function, maximum of z. So maximum of z is equals to x1 coefficient, x2 coefficient, x3. And so these are the adding variables, x4, x5. So these are the adding variables, zero coefficients, 1, 2, 3, 0, 0 into x1, x2, x3, x4, x5. x1, x2, x3, x4 transformation. So we can multiply, we are getting x1 plus 2x2 plus 3x3 plus 0 into x4 plus 0 into x5. So this is the maximization, maximum of z in matrix form. So next, constants. So constants in matrix form, the equation 1, 1, 1. So 1, 1, 1, x1 coefficient 1, x2 1, x3 1, x4 minus 1. There is no x5, 0. So next, in second equation, 1, 2, remaining all are zeros. 1, 2, 0, 0, 0. So next, in third equation, 5, minus 2, 3, 0, 1. So this is the matrix into x1, x2, x3 up to x5, all variables, x1, x2, x3, x5, and constants, 3, 5, 7. So this is the matrix form of LPP. Matrix form of LPP, given LPP. So next, simplex method. Simplex method. So this is the procedure to find out the simplex method algorithm. Simplex method. In simplex method, first to convert the given LPP into standard form. Standard form. So next step. So this is a simplex table. So this is the simplex table. So this is very, very important table. So the BV is nothing but basic variables. Basic variables. Basic variables is nothing but, so in previously we can add x4, xy, x6. So these all are basic variables, x4, x5, x6. So these all are basic variables. So next, CB. CB is nothing but RHS of constants. So So these are CB values 3, 5, 7. So basic variables are here. Basic variables in this question, in this problem, basic variables are only two variables, x4 and x5. So these are adding variables of the LPP. So these are the basic variables. CB is nothing but 3, 5, 7. 3, 5, 7. And XB. XB, X1, X2, X3. So this is as this matrix. So previous matrix, X1, X2, X3. These all are matrix. X1, X2, X3 up to third one. So this is the matrix. So this is the formula, important formula. Delta J is equals to Zj minus Cj. If all delta J's are greater than or is equals to 0, then the solution is optimal. The solution is optimal. Then stop the process. If at least one of the delta J, is greater, less than or is equal to 0, we can continue the process up to all the delta J's are greater than or is equals to 0. This is the process to. So example 2.5, maximum of z is equals to 3x1 plus 5x2 plus 4x3. So subjected to constants, 2x1 plus 3x2 less than or is equals to 8, 2x2 plus 5x2 less than x3, x3 less than or is equals to 10, 3x1 plus 2x2 plus 4x3 less than or is equals to 15. All the x for x2, x3 greater than or is equal to 0. First, we can convert the given LPP into standard form. Objective function should be maximum. Is already maximum is there. No need to convert. And all the constants inequalities to convert equalities. So that is less than or all are less than or is equal to 0. So we can convert less than or is equal to 0 to equality. Second point. Next. So we can represent standard form into matrix form. After we can represent standard form into matrix form. Is writing directly. So his maximum is there. So we can add variable x4. The first equation we can add plus x4. The next second one also x5. The next third one also x6. All equations, first constant, second, third. So 2x1 plus 3x2 plus x4 less than or is equals to 8. First equation. 2x2 plus 5x3 plus x5 is less than or is equals to 10. Next, 3x1 plus 2x2 plus 4x3 plus x6 is equals to 15. Next, x1, x2, x3, x4, x5, x6 all are greater than or is equals to 0. So this is standard form. Standard form is nothing but in simplex method. So we can add x4, x5, x6 to constant to convert inequalities to equalities. So next, matrix form. Representing matrix form 2, 3, 0. There is no x3 in first equation. There is no x3 in first equation. So next x4, x5, x6, 0, 0. So next second line 0. There is no x1, 2, 5, 0, x5 value 1. Coefficient x6, 0. Third line 3, 2, 4, 0, 0, 1. x1, x2, x3 up to x6 is equals to 8, 10, 15 here. 8, 10, 15. Simplex table. First we can write basic variables. So basic variables are here and here x4, x5, x6. x4, x5, x6. So these are the basic variables. So CB is nothing but 0, 0, 0. In first simplex table, CB is always, CB is nothing but here. So these values. x3 coefficient in objective function, x4 coefficient in objective function, x5 coefficient in objective function, x6 coefficient in objective function. So these are CB values. So these are CB values. So next, XB is nothing but 8, 10, 15. 8, 10, 15. So next step, so we can write the same matrix on here. 2, 3, 0, 1, 0, 0. First row, second row, third row. So x1, x2, x3, x4, x5, x6. So next, top of the table, CJ. CJ is nothing but coefficients of x1, x2, x3, x4 up to x6 in objective function. Here objective function coefficients are x3, 5, 4. Remaining all are zeros. So 3, 5, 4. Remaining all are zeros. Here minimum ratio. So minimum ratio formula xb by x. xb by x. So this is the minimum ratio. So next we can calculate delta J. So delta J. So how to calculate delta J? So here CB into XB, CB into XJ. So first X1 we can calculate. So this is multiplied by X1. So how to multiply? So 0 into 2, 0, plus 0 into 0, 0, plus 0 into 3, 0, minus CJ. So formula CB into XJ minus CJ. Delta J is equals to CB into XJ minus CJ. Direct formula. So 0, 0, 0, minus 3. So the last final answer is minus 3. So next, CB into XJ minus CJ. Next, X2. X2. So this one into CB. 0, 0, 0. All are zeros minus 5. So minus 5. So next, X3. All are zeros. 0 into 0, 0. 0 into 0. 0 into 5, 0. Plus 0 into 4, 0. All are zeros minus CJ. Minus 4. Next, the remaining also 0, 0, 0. All are zeros. Is clear? So delta J formula, delta J is equals to CB into XJ minus CJ. CB into XJ minus CJ. Delta J formula.
సార్ సమ్మేషన్ ఆఫ్ సిబిఎక్స్జే కదా సార్?
Summation of CGXJ. So adding all these terms. So like this. First step. So CB X1. So multiply first term 0 into 2, 0 plus 0 into 0, 0 plus 0, 0 plus 0 into 3, 0. All are zeros. Minus CJ, minus 3. That is minus 3. So next, second also, second, X2 also same. X2 also. CB into X2. CB into X2, 0 into 3, 0. 0 into 2, 0. 0 into 2, 0. Adding all these three terms. 0 plus 0 plus 0. Minus XJ, CJ. So that is minus 5. Next, x3. x3 also same. Remaining 0 summation of cb into xb, xj minus cj. 0 plus 0 plus 0 minus 4. So this is minus 4. So remaining also all are zeros. So in these negative values, so most negative value. So most negative value is most negative value is 5, minus 5. So here the most negative values, all delta j's are the most negative delta j corresponding to x3, x2. The most negative value is minus 5. So therefore x2 is entering variable. So this is the most negative value compared to these three negative. So this is the most negative value. So that is least value. Least value is minus 5 compared to remaining all variables. Only we are taking negative values. So here, so this is x2 is entering variable. x2 is entering variable. That's why we are taking here upper RMR. So next, leaving variable. So we can identify leaving variable by using minimum ratio. So minimum ratio. So minimum, how to calculate minimum ratio is nothing but xp by x2. So which variable is entering variable. So x2 is entry variable because so all the negative values, least negative value is minus 5. So this is entry variable. So we can identify exit variable xp by x2, 8 by 3. So that is nearly 2.2 by 3. Next, 10 by, so this is divided by x2, 8 by 3, 10 by 2, 15 by 2. So So minimum ratio in these three values, minimum is nothing but 8 by 3. So this is entering variable, exit variable. So x2 is entering variable, x4 is exit variable. Is clear? So intersection of entry and exit. So this is called key element. Key element. So this is called key element. Entry variable is x2 because the most negative value is nothing but least negative value is x2. So this is the entry variable. So next, they can identify exit variable by using minimum ratio. So xp by x2. So here 8 by 3 is negative, 8 by 3 is minimum. So this is the exit variable. So this is exit variable. So this is entry variable. So intersection of exit and entry variable is called key element. So this is key element. For example, in this minimum ratio, so minus 5 is there. So minus 5 is there, 7 is there, 0 is there, or 0 or 2. So we cannot consider negative values on minimum ratio. So we cannot consider negative values on minimum ratio. We can take only positive values. If the two values are negative, so we can take remaining value, maybe negative, uh, only positive value. We can consider only positive values in minimum ratio. You know? So next class we will continue on next class. Simplex method. So three methods are important methods: simplex method, big game method, two-phase method. Two-phase method. So these three methods are important. So every time we are getting long questions of these three methods: simplex method, big game method, or two-phase method. Long question వచ్చింది అనుకోండి, ఇంకొకటి షార్ట్ క్వశ్చన్ వస్తుంది. కన్ఫర్మ్ గా త్రీ మెథడ్స్ నుంచి టూ మెథడ్స్ కన్ఫర్మ్ వస్తాయి. లాంగ్ క్వశ్చన్ వస్తే రిమైనింగ్ టూ మెథడ్స్ నుంచి ఒకటి షార్ట్ క్వశ్చన్ వస్తుంది. కావాలంటే ప్రీవియస్ పేపర్స్ వెరిఫై చేసుకోండి ఒకసారి.
సార్
ఎనీ
మీ
డౌట్స్?
మీ నంబర్ చెప్పరా సార్? పీడిఎఫ్ పెడతారా? పెడతానన్నారు కదా సార్ పీడిఎఫ్.
నేను మెసేజ్ చేస్తా చూడండి అన్న ఇప్పుడు. ఆపరేటర్ థియరీ అనేది వేరే సార్ చెప్తారమ్మా. ఆపరేటర్ థియరీ లింక్ కూడా ఉంటుంది, చూడండి ఒకసారి అందులో. ఆపరేటర్ థియరీ లింక్ ఉంటుంది అందులో మీ దాంట్లో. ఆపరేషన్ రీసెర్చ్ ఈ టాపిక్ ఉన్న వాళ్ళు ఇది వినండి. రిమైనింగ్ పీపుల్స్ ఆపరేటర్ థియరీ ఉంది, క్లాస్ జరుగుతుంది. ఆపరేటర్ థియరీ మెసేజ్ చేశారు కదా, ఆపరేటర్ థియరీ కూడా ఉంది, చూడండి ఒకసారి అందులో. మీకు ఇచ్చిన సైట్ లో లింక్ ఉంటుంది, ఆపరేటర్ థియరీ క్లాస్ కూడా ఉంది.
ఆపరేటర్ థియరీ అది అప్లైడ్ మ్యాథమెటిక్స్ ఏనా సార్?
అది కూడా ఉంది. ఇది కామన్ పేపర్. ఆపరేటర్ థియరీ కొందరు తీసుకున్నారనుకుంటా, వాళ్ళకి కూడా ఉంది, చూడండి ఒకసారి అది.
సార్ ఈ సబ్జెక్ట్ లో ఇంపార్టెంట్ చాప్టర్స్ ఏమైనా ఉంటే చెప్తారా సార్? అంటే నేను 10 మార్క్స్ వచ్చేది
ఇప్పుడు చెప్తే
ఖచ్చితంగా వచ్చేది.
ఇంపార్టెంట్ టాపిక్స్ నాన్న. ఇప్పుడు చెప్పిన టాపిక్స్ ఇప్పుడు చెప్పాను కదా ఇందాక, ఏంటి సింప్లెక్స్ మెథడ్, బిగ్ ఏ మెథడ్,
అంటే
అంటే
టూ మెథడ్.
సబ్జెక్ట్ మొత్తం సార్, ఇంపార్టెంట్
సబ్జెక్ట్ మొత్తం
చాప్టర్స్.
ఉంటుంది.
నేను రాసి పంపించేస్తున్నాను, ఒకరికి పంపించేస్తాను, మీరు షేర్ చేసుకోండి నా దగ్గర నుంచి.
సార్ గ్రూప్ లో దీంట్లో మీ నెంబర్ పెట్టండి సార్ చాట్ లో.
పెట్టాను చూడండి ఒకసారి,
ఓకే
పెట్టాను
సార్.
ఒకసారి. నెక్స్ట్ క్లాస్ తో కంటిన్యూ చేస్తున్నాను. ఓకే.
థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్.